So SQL Replication Project Update, we've presented this subject a couple of times before in previous conferences, but in the last 12 months, quite a lot of stuff has changed, and we've made quite a few improvements and changes to the environment, so I thought we'd take this opportunity to present it again. So I'm going to be talking about the basic principles of SQL replication, what it is, what it does, why we use it, and how. Most of the slides are just updating you on things that have changed recently and improvements that have been made. And also towards the end, I'll give you a couple of pointers of how to get started. Actually, I'm going to give you a demonstration of how to get started fairly early in the presentation. So the basic principles of this environment that we're talking about here are coming up with a mechanism to allow us to take data from one or more files of our application's data files and replicate that data to matching tables in a relational database. We want to do that in as close to real time as possible. It's not absolutely real time, but it's pretty close, usually within a couple seconds if everything's working smoothly and just processing normally. We are accepting that this is a one-way replication only. This is not a two-way replication, so the database is to be treated as a read-only environment for the purposes of reporting or analysis or data warehousing or whatever it is you want to do. But this is a one-way replication out of Synergy and into a database. It has to be something that's easy to implement, and when I think of easy to implement, I'm thinking, we go into a new environment and we want this thing to be up and running in a matter of days, not weeks. We want to make minimal changes to the underlying original application, and I think we've been successful at that at this point. We want minimal performance impact on the original application. Clearly, we have to have some performance impact because we're doing additional work, but we want to minimize the impact on the performance and certainly not introduce anything that users would be aware of. And we want to do this at a minimal cost. So those are the goals for this environment. So the approach that we've taken in the environment is to provide code in a core environment. So there is a library of routines that is pre-written and pre-supplied, and that's generic code, so it doesn't need to know anything about your application, your data files, or your keys, or anything like that. And it provides a framework for doing the replication. So all of that code is already written. We also provide a pre-written replicator process, so that's a traditional Synergy program. So this works on Unix, on OpenVMS, on Linux, on Windows, and so on. It has been built in as a .NET application as well and does work. So it works. This can work in all of our supported environments. So that replicator process program and various supporting utilities to let you start it and stop it and figure out what it's doing and send it instructions and things like that. All of those things are pre-written. We also rely fairly heavily on code generation in this environment. Ultimately, what we're dealing with here is a traditional Synergy DBR using the SQL Connection API to interact with the SQL Server database. And all of that, if you've ever done SQL Connection programming, you will know that SQL Connection code tends to be very, very file specific or structure specific. You're dealing with, column names and so on. So it's not possible to write generic routines. So CodeGen is ideal for this because we can take the metadata in our repository and generate all of the SQL code that we need. And that's exactly what this environment does. Per structure that we're replicating, we generate a whole bunch of subroutines and functions that do things like create a table that looks like this file in the database, delete the table, upload data to the table, insert a row, delete a row, and so on. So we generate Synergy subroutines and functions that do all of those specific database operations per table. Then we plug in the environment into your original application. And the mechanism we use to do that is I/O hooks. So one of the provided routines is called xcore configure replication, and what it does is you pass it a channel number, it looks at that channel and says, is this channel open for update? Because that's the only time we need to do any replication, and it says, is this a channel to a file that I've been told we are replicating? And if so, it adds an I/O hooks class to that channel, and that I/O hooks code is pre-written and records changes that are made on that channel. So from that point on, any create, update, or delete is tracked by the I/O hooks code by recording information in what I call a change queue file. That queue file is just an ISAM file. The overhead on the original application is whenever there's a create, update, or delete, there is one additional ISAM store into the queue file. So that's pretty much the overhead on the underlying application. What the replicator does is it runs as a detached process or a Windows service, and it simply looks at that queue file on a periodic basis. It says, is there anything to do? And typically, it will find items in the queue file, and it simply works through those items in the queue file, affecting the equivalent change in the relational database. So there are about 15 different types of instructions that can go into that queue file, but essentially the three main ones are a record was created, a record was updated, or a record was deleted. And accompanying that information in the file is the full data of the record that was created, updated, or deleted. So the replicator just reads the instruction and it says, oh, this was a create for this file, and here's the data. Go call customer_insert, that was the code-generated routine that adds a row into the customer file or customer table, and it moves on, it deletes that instruction and moves on to the next one. So it's actually a fairly simple environment. We use naming conventions heavily to allow generic code to be used. What the replicator does is it uses xcall xsubr, so it's totally generic. It doesn't need to be rebuilt to add files to the environment. If it sees an insert for the customer file, it's going to xcall customer_insert and pass the data. So it's a real simple environment. It simply operates in a processing loop. If it runs out of work to do, it goes to sleep for a period of time that you can configure. Most implementations that I've seen configure it for 2, 3, 4, 5 seconds perhaps. So if it runs out of work, it'll go to sleep for a couple of seconds, wake up, do it all again. And that's it, simple environment. The previous slide was representing the original application, and this slide is just describing those changes. So we use I/O hooks to record data to a queue file, process those items, and mirror those changes into the relational database. Replicator capabilities. The replicator is able to do the basic stuff we just described. It also has the ability to create the table in the first place. It has the ability to add indexes to the table. Whenever a table is created, the database table has a primary key that matches the primary key segments in the ISAM file, and optionally you can choose to add add indexes that are mapped to all of the alternate keys in the ISAM file. Because if those keys existed in the ISAM file for reporting purposes and things like that, there's a high chance that you might want those same indexes in the database. You can also, on the fly, delete those indexes if you wish, and you can delete and re-add the indexes at any time. That's a new feature. We use that to improve some bulk load time. It also has the ability to delete a table in the database. The replicator also has initial data management capabilities, so it has the ability to load a table is one of the instructions. You can create and load the table as a single operation, and one of the new features that we've added recently is the ability to bulk load a table, which is very significantly faster, and I'll talk about that in a few minutes' time. It also has the ability to delete all of the rows from a table, insert, update, delete, we've talked about already, and there are some replicator management instructions that you can send it as well. So you can change its processing interval on the fly. You can tell it, if you've got logging enabled, you can tell it to close and reopen the log file. You can tell it to purge all instructions from the queue file if you want to clear things down because something's gone wrong. These are really debugging, more useful in debugging scenarios than anything else. You can tell the replicator to close a certain file and it will reopen it the next time if it needs to, if it encounters an instruction again. And you can send it an instruction to stop processing. So before we go any further, I'm going to give you a little demonstration of the sample environment. Primarily so that if you were interested in playing with this, just to show you how easy it is to get up and running. So what I'm going to do first of all is I'm going to go off to in fact it's already open down here. Here you'll see is the GitHub replication homepage, so it's a repository called SQL Replication. What I'm going to do while I'm here, and this is how you would go about grabbing the code if you want to, this link here, clone or download, I'm just going to copy that URL, which is the URL to clone the repository. But while I'm here, I'm just going to go off to the wiki, so you'll notice there's a wiki link up here, and this is where you'll go for documentation. So I used to have documentation in a Windows help file, but I thought it was probably more accessible to just use the wiki on the GitHub site. So there's a brief description of what the environment is and how it works. And basically, if you're new to this environment, I'd recommend you just work your way down the list of topics here on the side. It will give you an overview of what the thing is, how it works, how to download the code, how to configure it, and so on. You will find that if you read this, the sample environment is pre-configured, assuming a local default SQL Server instance and a database name called SQL Replication. If that is the case, then you should be able to just download the environment out of the box, build it and run it, and it should all work. If not, then there is information in these topics that tells you if your database is on another machine, or if your database has got a different name, what tweaks do you have to make to the settings, changes to the connect string, and so on. So the information here should be enough to get you up and running. I'm also going to point out that there is optionally, if you go back to the main repository, you'll notice that we've got binary releases associated with this thing. Part of the code in here, I have this little thing called file service. And what file service is used for is to facilitate the new bulk load mechanism that I've built. So the old mechanism used to read 1,000 records from the file and do 1,000 inserts into the database, and read another 1,000 and do 1,000 inserts. What this new mechanism does, if you install file service on the SQL Server system, what it is a Synergy.net Windows service that hosts a Web API RESTful web service that accepts bulk uploads of files, okay? So the new bulk load mechanism exports the entire ISAM file to a CSV file, or it's not actually comma separated, but a separated file, and injects it up onto the SQL Server through that RESTful web service, and then does a bulk load, a bulk insert on the server system. And it's very, very much faster, in the order of about 20 times faster than the previous load mechanism. So I'm going to download this little MSI file installer, and I'm going to run the installer on my system just to get file service up and running. Again, you would normally do this on your SQL Server system, but that happens to be my local system here. And once it's up and running, there is an item in the Start menu. There's some documentation in the Start menu now if you want to know more about what it's doing. But there's also a little URL. It runs on port 8080 by default. That is configurable. And it has an operation called file service ping, that if you just go there, it will just say file service ping response. So that just tells me the thing's up and running, and it's now ready to accept upload instructions. So the next thing I'm going to do is we'll go and clone the Git repository. So I'm going to just open up a command prompt window, and I'm going to say git clone, and I'm going to insert the URL that we copied, and we're going to copy the code. So this is downloading and cloning the Git repository to my local system. So this is exactly how you guys could get the code as well if you wish. Clearly we're suffering from a slightly slow network here, but it's only a few megabytes. There we go. So now we've got a copy of the whole environment. It will have created a directory called SQL Replication, which I'm going to CD into. Again, following the instructions on the wiki, the first time you do this, there's a little batch file called setup.bat. What this does is two things. It loads the repository schema into a repository database, and it loads a couple of sample ISAM files with some sample data that are exposed. So now we have a repository and we have some ISAM files. Assuming my SQL Server is local, default instance, and called SQL Replication, I should be able to just work in this environment. In fact, here's SQL Server Management Studio. You can see I've got a database called SQL Replication. Sorry, I'm assuming it's going to use Windows authentication against this database as well. So if any of those things are not true, there's a description of what you need to change in the connect string and so on. You can see I've got a SQL Replication database. I'll do a refresh on the tables. There are no tables in the database right now. It's literally I've just done a file new database, and that's all I've got right now. So let's go ahead and open the environment. If I do a directory, you will see that there is both a Workbench workspace and a Visual Studio solution. This is all traditional Synergy. So there is a Visual Studio and Workbench environment. I'm going to use the Visual Studio, so I'm going to open SQL Replication.solution. Of course, it opens on the other screen. So this is what the sample environment looks like. There's a bunch of solution folders with CodeGen templates and the regen batch file and documentation and readmes. You'll notice there's also a VMS directory that's got VMS build scripts. There is also a Linux directory that's got Linux build scripts as well. So if you want to deploy this stuff to Linux or VMS, it all works just fine over there. It's been regularly tested. There is a library, well, here's the file service, web service, and its installer. You shouldn't need to mess with that because you can just download the MS. If you want to build it yourself, you can. The important parts of this are library is an ELB. These are those supporting routines that I talked about. One of them is, this is a single file environment, so you'll find a file called employee SQLIO, which we have to wait for Visual Studio to do its delayed load thing. So this is the one file in this environment that's code generated. This works very much the same way that code generation is going to work in the workshop tomorrow. There's a script file called regen.bat, and here I'm naming the structure. So if you wanted to plug your own repository in and generate this stuff for your own code, all you would have to do is list your structures here and regenerate the code. Run regen.bat in this environment, and it would generate SQL code for your environment. You might have some work to do. There are notes about setting up the repository and what you have to do and things like that. But the basics are, you name the structures, you generate the code, you add the code to the ELB, and off you go. The other main part of this environment is a project called Replicator, and this has a bunch of mainline programs. So there's the Replicator itself. I'm going to set Replicator as the startup project, and I'm going to set, there's a program here called Replicator Menu. I'm going to set that as the startup object. Replicator Menu is just a little command line utility that it's really a development testing tool. It's not intended for production use, but it lets you start the replicator, stop it, purge its queue, view its queue, tell it to create a table, things like that. So all I'm going to do first of all is I'm going to build and run the project, and it will run the Replicator Menu program. They are very simplistic programs. Again, this stuff works on Linux and OpenVMS as well, so I know they're not pretty, but they do work across all of the platforms. So the menu, here's the things we can do with the replicator. I can also tell it that I want to set a current table, and the table in this environment is called employee. And then I get various options, so I can tell the replicator. Now, if I issue these commands, all it's doing is writing instructions to the queue file. Nothing's going to happen yet because the replicator's not actually running right now. Okay? So if I start the replicator process, SR, that basically launches it as a desktop app. Now again, normally you'd run this as a detached process or a Windows service or something like that. Running it this way is really just for development and testing. But the replicator is now working. It's connected to the database. By the way, all of its configuration info. Oh, somebody needs to tell me when I do that. Okay, here they are. Sorry, there's the menu. Okay, here's the replicator running. All of the configuration in the Visual Studio environment, by the way, is provided if you go into Project Properties and go to Common Properties. So here's all the configuration settings, including the connect string that's used to connect to the database. So there are instructions in the wiki about changing these settings and pointing to a different database, but this is how you configure the environment, basically. In Workbench, it's in Project Properties in the Workbench environment. In Linux and VMS, there are setup.com or setup.sh scripts to set these various environment variables. So that's how you configure the environment. So the replicator is running. We know we've got an empty database. We've looked here. We don't have any tables. The replicator is telling us that it has successfully connected to the database, okay, and it's processing instructions. So another thing we can do here, I could go in here and say, let's manually create the table, and then let's bulk load the table, and then let's start doing things. But if I just go into a sample maintenance program, which again is provided in the environment, it's a very simple little program that just creates updates and deletes records in the employee file. So I'm going to say employee number 1, I'm going to say change the first name to whatever value, and let's do E to exit, and this will do a write on the ISAM file, and within a couple of seconds, the replicator steps in and says, oh, I got an instruction to update a record in the employee file. And it says, okay, this is the first time I've seen the employee file. Let's check out a few things. Do I have the file open? Oh, no, I don't. Okay, so I've opened the file now. I better look in the database and see if the table is there in the database. Oh, it's not. Okay, so I'll create the table in the database. I've done that. I've just created a table. I better put the data in there. So it's used the bulk load mechanism. It verified that it could talk to file service and then chose to use bulk load. It then exported the entire file to a pipe-separated file, uploaded it via file service to the file server. The uploads, by the way, go in 5 megabyte chunks. So I've tested this with a 10 gigabyte file and had no issues whatsoever. So you can bulk upload big things. Then it did a SQL bulk insert into the database. It completed that. There are 25,000 records in my sample data, and you saw it happened in less than a second. I don't know exactly how long it takes, but the whole process for those 25,000 records took less than a second. It looked at the file and said, oh, key 0 is unique, so I'm going to use that to synchronize between the database table and the ISAM file, and then it started replicating, so it did the change to record 1. Okay? So it brought the whole thing into existence, and now if we look in the database and do a refresh, we should find that we have a table called dbo.employee, and if we look in the table, we should find that we've got 25,000 records in there. Okay? Let's get back into here. So let's now look at so bear in mind we've updated the record once. Let's do a different one. So I'm going to say employee number 2, and I'm going to change she just got married, so let's say the last name is going to change to whatever. We'll do Smith. Okay, so if we notice in the database right now, employee number 2 is Avril Mason. Okay, let's go back to the maintenance program and look at the replicator, and we'll save that away and exit. Within 2 seconds, there's the replicator made the change, and if we now refresh the data in the database, we should find that that data is reflected in the database there. Okay, so that's the basics of how SQL replication works. All right, so to continue on so you've seen the basic demonstration of getting the sample environment out of GitHub. Showed you briefly that there's a batch file in the root directory called regen.bat, and in there's a place to name structures, and then that file will generate SQL code for your environments as well. There are some repository setup requirements and steps. One of the wiki pages talks specifically about that. You don't need a fully defined repository as long as you've got pretty much primary keys, assuming they're unique, or at least one unique key defined in each file or each structure. You don't need relations defined for this. It doesn't use them. You basically need structures, fields, a unique key at least defined, and files defined. Just to give you guys an idea of what this thing is capable of doing, this is just a snapshot from an end user, one of Phil Nicastro's end users called Mavis Tire. Phil just gave me this a couple of minutes ago, and what this graph shows is in the middle of the day, actually, from about 11:30 a.m. through 12:30, apparently the day end didn't run the previous night, so the CEO just came in and said, kick it off now. Okay, so there's a bunch of posting and updates happening during the middle of the day there, and you probably can't read the numbers along the side there, but the number at the very top of the scale there says 1,160,000. So that's the number of operations that were happening at this point. So up here, it's in the order, and these time slices are 15-minute time slices. So it's in the order of doing over 1 million transactions per 15-minute slice, perhaps even a little bit more. And as you can see, it came down. This is kind of just normal processing, bumbling along, doing 5, 10, 15, 20,000 changes every 15 minutes. Obviously, you can see some spikes during the day. Here was what does that say? I think that was a spike at 5 a.m. and another spike at 6:30. So there's some stuff happening on the system, and a large number, 200,000 or 300,000 records getting changed or created or something. No idea what that was. So I just thought you might be interested in that. You know, that shows you the kind of capabilities in terms of throughput. This is a very large end user system that I think is 2,200 users or thereabouts. 2,300 users on a Linux machine at this point in time. So they're pushing, I've never looked at the whole numbers, but I'm guessing they're pushing tens of millions of changes a day through this thing. We recently put our new bulk load mechanisms and things in there, and it made a huge difference for them. It brought things down from hours to minutes in many cases in terms of getting initial loads done. Okay, let's move on because I don't want to take up too much time. So in terms of setting up your replication environment, you do need a repository because it is based on code generation. You need basic structures, fields, keys, tags if you've got multi-record files to identify and discriminate between record types and files defined. You then just simply generate the SQL connection code for each of your structures. Very similar to what you'll be seeing tomorrow. There's a batch file. It has an environment variable called structures. You just list the structures, and it will generate a source file in the library project for each of those. So if you have a customer file, it'll be customer SQL IO. If it's employee SQL IO, vendor SQL IO is what it will create. Add those into the ELB. There are some requirements, things you have to have in place. You might need to look at some of your fields and how things are defined. But generally speaking, if it's a fairly standard type of typical record, good chance it'll work out of the box. We do have implicit support for things like D8 dates and D6 times and D4 times and things like that. If you've got weird date and time formats, you might have a little bit of work to do, but not too bad usually. To plug a new file into your environment, you have to edit one source file. There's a file I mentioned earlier called configure replication. There's a big old using statement in there, and you simply list the name of the file, and if you want to replicate, you do a new IO hooks ISAM, pass the channel number and the name of the table in the database, which is based on the file name or the structure name. And then you add xcall configure replication into your code wherever you open channels for update. Typically, for a lot of people, there's a file open subroutine, so typically there's one or two places in the code where you need to inject that little xcall configure replication call. And then that's where the IO hooks are added. And that's literally the only change to your underlying applications in most cases. Let's look at some of the changes and some of the things that have happened since we last presented this subject. Basically, we've changed the format of the queue file. The queue file used to have an A20 transaction ID, which was actually populated with a date time number, so it's just an increasing number. It has an action that says what kind of operation, create, update, delete. There's an enumeration in the repository that lists all of those things. It has the name of the structure, which is an A32, and it used to have a replication key, which is a unique key value based on an A20, again, usually populated with a date time value. The current queue file looks somewhat different. We now use an I8 auto sequence key in the file. We still have the action, we still have the structure name, but now instead of recording the key of the item that changed, we record the full record. The replicator used to have to read the transaction file or the change file and then go and reread the ISAM file to obtain the data. So by storing the full data, we've reduced the number of extra ISAM IOs from 2 to 1, basically. So we half the amount of ISAM IO. Change queue auto sequence key was actually a big deal. It turns out that %date time really isn't very granular in terms of how fast systems operate these days. And I didn't realize that the replicator, when it tried to inject into the instruction queue, was actually hitting a duplicate key over and over and over and over and over, and it had a tiny little sleep in there for like 1,000th of a second. And that was actually, as it turns out, a major bottleneck in this whole environment. We changed that to an I8 sequence key, and all of a sudden the whole thing got like 60% faster. It's amazing how much of an impact that had. So if you're using A20 for stuff like this, where you're putting a lot of stuff into a file, you might want to really review that, because it was a major deal. And it was like one day, oh, wait a minute. ISAM file requirements. The previous behavior was in the older environment, the ISAM files must have a unique primary key, okay? And if the file did not have a unique primary key, we required you to add a new key to the system and name it replication_key. And that was an absolute requirement. Now, in the current implementation, the replicator will look at the file when it first opens it, and it will go out looking for a unique key. It doesn't matter which key it is. If the primary key is not unique, it will look at key 1, key 2, key 3 until it finds a unique key, and that is the key it will use to synchronize changes between the file and the database. So as long as your file has at least one unique key, then you're good to go with replication and you don't have to change the file. If it doesn't, then I'm afraid you still have to add one, and every now and again we come across that. But that made it significantly easier to implement replication in most cases. We've also recently added relative file support. This was just done a few months ago. All we're doing is we inject a virtual record number field into the beginning of the table in the database. We use the relative file record number and we add a record number field into the database and hook things that way. You'll notice in the environment there is a separate IO hooks class. There's now an IO hooks relative and IO hooks ISAM. So when you're editing configure replication, you need to use the appropriate IO hooks class based on whether it's an ISAM file or a relative file. Another recent change I mentioned earlier is we introduced a new way of bulk uploading data. So this little file service, Windows service that you can download and run on the database system, basically allows the replication server, if it's running on a different system. Now, if everything's running on one system, you don't need this, clearly. You can create an export file. You know, if you're running the replicator on the database server itself, then it can create a local file already. But what this allows you to do is, if you're running your Synergy environment over here and your SQL server's on a different server, you can run file service on that server, and it allows us to very quickly unload the file on the Synergy environment and very quickly transport that file to the SQL server system, where we then do a local bulk insert. And again, on average, my testing is telling me that that's about 20 times faster than the previous mechanism, okay? So that enables bulk load. So bulk load, the difference here, again, I think I already mentioned this, so I'll go quickly here. What table load used to do previously was it would open the file, it would read 1,000 records into dynamic memory, and then it would call an insert rows routine, which would do 1,000 inserts, and then commit a transaction. And then it would do it over and over and over again. So essentially it was an insert for every record in the file. Bulk load exports it to a pipe delimited file by default, I believe, transports that file to the SQL Server via a RESTful web service that does chunked up uploads in 10 megabyte chunks if necessary, and then does a bulk insert from a local file on the SQL Server system again, and it's much, much faster. Index creation and removal, also in the old environment until a few months ago, we would automatically create indexes on the table at the point we created the table. And what we do now is we separate the creation of the table from the creation of the indexes, such that when we're doing a new table and we're intending to bulk load it, we can bulk load the table without all of the additional indexes in place, which is significantly faster. Well, it's not, maybe not significantly faster, but it's faster. And then we add the indexes afterwards. Okay? So that was another change. And you can also now, if you're going to do bulk operations on the table, there are new instructions to the replicator that you can tell it to go and remove all the additional indexes for a period of time if you're going to do some bulk operations, and then you can tell it to put them all back again. Another change that we made recently was we deal with clustered indexes a little bit better. So a clustered index in SQL Server defines how the physical data is organized and stored in the database. And you're allowed to have one clustered index per table, and it's usually the primary key. And having that clustered index generally is a performance optimization. SQL Server primary keys must be unique, but for ISAM files with a unique primary key, then we create the primary key as a clustered key. Previously, if the replicator chose to replicate or synchronize using an alternate key, because the primary key was not unique, then that alternate key would not be created as a clustered index. Now it is. Again, that was a specific request from this customer that we were just showing those figures from, and it seems to have made quite a big difference for them in terms of how they access the database and the performance of doing so. That one is, I think that's parameterizable as well. I think you can flip-flop that around to the old behavior if you want to do so. We also did some work in how we commit things to the database. In the old environment, again, until about 5 months ago, I think it was, we did most of this work. What we were using was essentially a manual commit mode. So what that meant was, in our generated SQL code, when we did an insert row or an update row or a delete row, we would start transaction, do the operation, commit. Okay, so we were committing a transaction for each and every change to the database. And all three of these are still available. You can select this through a configuration setting now. SQL Server has this auto commit mode that you can turn on. So whenever you do an insert, an update, or a delete, it automatically commits the transaction yourself. So there is an auto commit mode. The advantage there is that, remember, these are typically SQL connection individual operations over the network. Start transaction, do it, commit. So by turning on auto commit in the database, we get to do one SQL connection instruction to the server instead of 3. And SQL Server just automatically commits it. So we did see a noticeable performance difference by doing that. But then I think this one actually came out of Roger's head. He said, well, why don't we just do a batch commit mode? So now the default behavior is that the replicator processes batches of information together. So it basically starts a transaction, and then it just keeps operating and keeps doing things, and it collects things together in a single transaction until one of 3 things happens. If the replication queue or the change queue becomes empty, so the replicator is going to sleep for a couple of seconds, it will commit whatever is outstanding at that point. There is a cutoff point that is configurable, but by default it's 1,000 rows. So by default it will commit if it hits 1,000 and then start over. Or if there's a major event like a create table or a delete table or something like that, it will commit at that point as well. And that one gave us a fairly significant performance improvement as well. But you can revert back to either 2 of the other mechanisms if you wish. We've also improved the shutdown mechanism. The shutdown mechanism previously was it just queued a command that said stop. But the problem is, if the replicator is doing a bulk load of a table that's got 50 million rows right now, and the system is operating, so the queue's getting longer, right? Things are queuing up behind it. Well, the stop instruction might be 2 hours from now in some cases. So what we now do is we manipulate things in the queue file so that when you issue a stop, it actually gets queued at the head of the queue. So if it's doing a bulk load, you still have to wait for the bulk load to finish, but it will be the very next thing that happens. So it allows you to stop the replicator that much faster if you wish. At the end of the day, it's not the end of the world if you have to kill the replicator, because if you kill it, even if it's in the middle of processing something, that instruction is still in the queue file. So the next time you restart the replicator, it's going to start over doing the same thing. You might need to clean up the data and think, oh, well, I killed it in the middle of a bulk load, so let me go and clear that table because it's going to do it again. So you might have to put some thought into what you need to do to the database. But generally, it's not the end of the world if you kill it off. It'll just pick up where it left off. Multiple replicator instances. We now have a mechanism to support running multiple instances of replicator on a system at the same time. This is not to be used for individual files within a single data set. In order to preserve the sequence of things, it's important that you have one replicator updating this data set. But if you do have a system that's supporting 2, 3, 4 multiple instances of the business with completely separate data sets, you can now name the instance and run an instance of the replicator for each of those business entities, essentially. Okay, optional data cleanup. It turns out that bad data in our ISAM files is surprisingly common, okay? Numeric fields that have alphanumeric values in them and date fields that don't have valid date values in them and things like that. It's surprisingly common. So by default, what the replicator does is every time it encounters a record, it looks at the value of every field and says, I know this is a numeric field. Does it contain a numeric value? This is a date field. Does it contain a date value? So it does a lot of extra work to validate the data so that it doesn't get errors when it throws the data at SQL Server. If you know your data is clean, there is a mechanism to turn that off, and that can be a noticeable performance improvement as well. But by default, it's checking every field. There is also a code gen template that will generate a program that you can run against each data file, and it will tell you the same thing. So if it encounters bad data, it will tell you about it. And, and in fact, it has an option to go and blank it out or zero it out or whatever if you wish. The problem is the bad data got there somehow in the first place. So there's probably something in your application that's allowing it to go there, and cleaning the file just once frequently doesn't actually help for that long. It might help for a while, but then the bad data creeps in there again. In terms of configuring Replicator there are now 2 mechanisms of doing it. Primarily, I tend to configure it through, there's about 20 environment variables that you can configure all kinds of stuff, from the connect string to the interval to where the database is to the to how max rows, max cursors, all kinds of things you can configure. There's now also command line options. So if you prefer not to use environment variables, and maybe you're registering a Windows service, for example, you can actually run replicator.dbr minus this, that, and the other all on the command line and specify it there. Those command line options and environment variables are all fully documented in the wiki as well. Replicator logging. Previous behavior was originally the replicator used to open and close the log file on each operation, which initially in most environments, it sounds scary, but in most environments it wasn't that bad. But when we got into Phil's customer with their 2,200 users and tens of millions of things a day, it turned out to be quite a problem. So now, if you've got a log file, if it's enabled, the replicator opens the log file one time and keeps it open. There is now a new instruction that you can issue through the queue file to tell it to close the log file and open a new one, if you need to go and edit it or view it while the thing's running. We've also added support for using system log logging, so through SynReport event. So there is an option to log, not everything, but error situations primarily through Windows Event Log or the operator log on VMS or syslog. The other thing I would say on logging as well is that logging is still quite an overhead. Even though we're not opening and closing the channel, doing that physical I/O is a noticeable overhead, and even if you've got a minimal level of logging turned on, you will notice it in terms of performance. So really the logging is intended to be for really developer debugging type scenarios. The replicator, as it says on this slide, does also support email notification now as well. So you can have it emails you if it encounters an error, or again, if major things happen, like a table getting created or deleted or bulk loaded. So I would recommend you configure the email environment and don't have logging enabled, and I think you'll probably see a performance benefit by doing that. Although, make sure your email's working, because on your customer side it's still not working, and there's a multi-second timeout trying to send an email. If it doesn't talk to the SMTP server, there's a timeout involved in there, so that can be a problem. Stop on error, there's also now an option, because if the replicator encounters an error, and the most typical error is it runs into a piece of bad data, and data checking either doesn't pick it up or isn't enabled. So there is an option to tell the replicator, if you encounter any problem, just stop processing. Okay, and the queue file will be in whatever state it was in, so you restart it, you would expect to get the same error. So you can look at what was the error, go fix it, and then restart it. Meantime, everything's still queuing up in the background, so as long as you resolve something fairly quickly, it can catch up. So once you get the thing in there, this thing just sits there and runs and does its thing typically. Once you've got the data clean and got the issues sorted out, it just sits there and does its job. So errors are not frequent at all. Database cursor use. Previously, we used to open and close cursors for every operation in the database, or every operation we did. Now, for the frequently used operations, primarily insert and update, we open a cursor for each of those operations the first time. So the first time there's an insert on the customer file, we create a cursor specifically for that, and we keep it around and reuse it. And the same for update. So 2 cursors per file being replicated, we keep around. And then for other operations like delete and create table, we still create a cursor, use it, and delete it. Okay, but again, we're keeping a lot more cursors open, but we're reusing them and getting better performance because of that for those common operations. Database connection configuration. SQL connection has the ability to specify the maximum number of columns on a table and the maximum number of cursors that you can have available. Both of those have default values, 254 and 128. We've now surfaced those settings through environment variables and command line options, so that you can control those in your environment. As you add more and more files or tables to the environment, at some point you're going to run out of that 128 cursors and need to allocate a few more. All it's doing is allocating a bit more memory to the process, and so on. The replicator menu utility we've added since the last environment. Again, it's really not intended to be a production thing, it's more for a debugging thing. But just bear in mind it's there to easily let you start the thing, stop the thing, view how many items are in the queue, purge the queue. And you can say, go into a table and cause the table to be deleted, reloaded, created. You can do that kind of simple operation. There is also a very simple little program that just reports to you how many items are in the queue right now. Although obviously it's just an ISAM file, you can find that information for yourself as well. We've also significantly reduced the amount of generated code. In earlier versions, we used to generate specific I/O hooks classes for each file and ISAM I/O routines for each file. Well, we're not doing ISAM I/O to the file anymore. All we read is the queue file. So now we just literally generate that one file of SQL routines for each of your files, and that's all. Everything else is pre-supplied. There is that one file that you have to edit to list the files that you're replicating, configure replication.dbl. Availability and documentation. The sample environment is fully available and fully tested. I test it on Windows, on Linux, and on OpenVMS periodically, and I know for a fact it works well on all three. And I showed you earlier there are command scripts and so on available to start it on Linux and OpenVMS as well. And like I say, I've did quite a bit of work on the documentation and moved it into the GitHub wiki, so that's where you'll find it. Getting started with the sample environment, you basically saw me do it today, right? You clone the repository, you run the setup script to create the repository data files, or put your repository into the environment if you're just going to start off by customizing it. Oh, well, no, with the sample environment, run that setup.bat, open up the project in Visual Studio or Workbench, build it. The one thing you're likely to have to configure is the database connect string. So again, if your database is not on the same machine with a default instance and called SQL replication, then you'll have to configure the database connect string environment variable. And there is a page in the wiki specifically about all the different combinations. Is it local, is it remote, is it a named instance, what's the username, password? So there's a thing there to help you. Getting started in your own environment, it's really a case of dropping your repository in there, following the requirements that are again documented for what you need to provide in the repository, generate the code, add that code to your ELB and give it a shot. there's a pretty good chance that you'll have something up and running fairly quickly. And you have to manually maintain configure replication to list the files you want to plug the hooks into. There is one other scenario where you may need to edit one file. If you have multi-record format files, there is support for that through the tags mechanism in the repository, but you have to also make a little edit to the bottom section of the IO hooks file as well. And you'll see it in there. There's a little mechanism that says what's the file name and what's the table, and it breaks out it's a way of calculating what the table name in the database is based on the tag that's being processed right now. So that's the second place you may have to edit code, only if you have multi-record format files. In terms of requirements and restrictions, ISAM files must have at least one unique key. Any key doesn't have to be the primary key anymore, remember, so that's not too much of a restriction. Because we're storing the whole record in the queue file, and we need a few bytes to store the table name and the instruction, the maximum supported record lengths are 65,000 and 32,000 on OpenVMS. So clearly, if you have a file that is at the absolute maximum record size, we're not going to be able to replicate that whole thing. Okay, but I haven't come across that as being a problem at this point. Repository has to have structures, keys, tags, and files. You do need Synergy version 10 or higher because it uses auto-sequence keys. And also bear in mind that means that there is binary data in the queue file, so don't be using isload and isunload or things like that. You need to be using fconvert with counted files if you're manipulating the queue file for any reason. You will need at least CodeGen 5.3.3 for this environment currently, but if you're using CodeGen, stay up to date with the latest version. In terms of Windows licensing, it will require one SQL connection license for SQL Server so that you can connect to the SQL Server database. If you're using file service to facilitate bulk uploads, it will require one Synergy runtime license on the Windows system to support the file service process because it is a Synergy.NET service. And you will require one runtime environment during development so that you can run CodeGen. On the Replicator platform itself, if it's not the same platform, again, Replicator is a Synergy program, so it requires one Synergy runtime license as well. And that's my product update for SQL Replication. Do we have any questions?
If your system has I/O channels opened and closed within each routine rather than in a central place, what would you recommend?
My recommendation would be quit doing that at this point. No, seriously, I mean, you're going to have to find, if you want to do replication, you have to find every file open for update of every file that you want to replicate. Okay, so
in version 11, we have a sort of global file I/O hook mechanism, so you can hook everything regardless of where the open statements are. So, not too far in the future, okay, you can just sidestep that issue.
Okay, good info. But for the time being, I would say if you're going to be making major changes throughout the code base to go find them all, just swap them all out. Just make a new file open routine and just go implement that throughout the system. It's probably not that much harder. You can do changes like that with search and replace and regular expressions and stuff pretty easily, or write a program to do it. That's what I would do.
Is integer data handled, especially as part of the primary key? We have a couple of old record structures that use a packed data to get around max sequence number.
Integer data is supported. I do not believe we have any support for packed data. I haven't seen a packed field in 20 years, but if you've got one... Yeah, no, but it's purely an issue in the CodeGen templates, so it could be modified to take that into account. Right now, the CodeGen templates specifically say alpha, decimal, integer, implied decimal. We would need to add a section to say what kind of field it becomes in the database and deal with it. But it's doable, but it wouldn't do it right now.
And the final question, if an ISAM file is replaced by a backup, can you reload the table?
I guess you could, there is a subroutine in our library called SQL Replicate, which is used by the I/O hooks to inject instructions into the queue. So you could run, if you're scripting the backup and you know that you need to reload a certain table, you could use SQL Replicate to inject delete table, create table, bulk load table into the queue, and it would follow those instructions. And if it's not a Synergy environment then you're in, then just write a program to do that and run that program from the backup script.
Okay. Thank you, Steve.
Thank you.